This is sort of the values that I was talking about, and this is the associated public key. So when you do that RSA operation, this comes out. If you see the zeros there, that means it's left padded with zeros, so those values wouldn't matter, and we traditionally wouldn't write them when we were writing them out on paper. But so there's some interesting consequences of the way IBM did this. Basically what you can do is you can write Trojan BIOS code and have a permeable area, an area that can change without harming the code that you've written. And you take that area and you change it until the SHA-1 hash matches up with the last 20 bytes of a perfect cube. It doesn't matter if the perfect cube is 20 bytes long. What matters is the last bytes must be a perfect cube. And basically you insert the cube root as a signature, and you've just defeated IBM's RSA implementation. I wanted to zoom in on that, but I can't remember why right now. So basically, that's the flaw inside the IBM TPM. I don't have a proof of concept today. Basically, all the people who raised their hands when they said they have Lenovo laptops, they're currently affected by this vulnerability. And we didn't do any proof of concepts today because we figured that explaining it, we figured that doing a proof of concept and showing it work would be a bad idea until IBM gets around to fixing that, which is going to be incredibly difficult. So the possible impact of this, who here uses the TPM? Yeah, so what do you use it for? Shout. Exactly, boot encryption. So basically, all of the boot encryption, when you thought previously that that boot password couldn't be sniffed by malware, I can take and write a piece of code and have IBM's TPM authenticate that as something legitimate and sniff that password and do whatever I want with it. Additionally, Bitlocker. Do people here use Bitlocker a little bit? Yeah, so Bitlocker uses the TPM, and basically you can use this to sniff people's passwords. So I'm going to pick on antivirus a bit more. So antivirus vulnerabilities are not new, but they are very rare, or at least there's not a lot of them that are found and reported. The peak here was in 2007 with 30 of them found, but this is also NIST.gov. Basically, it was just a simple search for antivirus and all the CVEs that matched it. So there might be some noise in this data, but in general, it gives you a good picture of how small the number of antivirus vulnerabilities that come out are. So here's several different CVEs. Basically, all of these vulnerabilities were found by Alex Wheeler, myself, or Neil Maida. There were lots of other vulnerabilities, but if you look at these, you can see that there's quite the smattering of different file formats that were affected. Basically, we have LHA. Does anybody use ARJ or even remember it? We've got some hardcore people, right? Yeah, there we go. So basically, all of those different file formats were vulnerable. And it's kind of difficult because the antivirus, in order to parse that file format, has to do the same thing that the actual software that's designed to manipulate those file formats does. And if those pieces of software have vulnerabilities, antivirus is as well. Also, there were several previous Black Hat speeches that talked a little bit about going into antivirus. Alex Wheeler and Neil Maida in 2005. I'm going to horribly mispronounce that last name, but Feng presented in 2008, along with Sinan Aaron. And those were presentations basically about having vulnerabilities in antivirus and how important it is to secure antivirus. So with all of this, with all of these different things that antivirus does bad, and with all of these different vulnerabilities that are introduced by antivirus, why do people still install antivirus? Because antiviruses detect malicious programs. Who believes this? I want a shout out. Yeah? No? Every once in a while. There we go. Perfect. We're waking up now. So anybody who does believe this should try to figure out why SVC host is malicious and why McAfee decided to brick all those systems. So who believes antiviruses make computers safer? Just that blanket statement. A little bit safer, right? It gets rid of the known vulnerabilities, and it gets rid of the known pieces of malware out there, and it definitely helps. It's better than having nothing, especially on end-user systems. But also you have to remember all those vulnerabilities that came out. Although antivirus does make you safer against some things, it's sort of a trade-off. There are vulnerabilities that you're introducing when you install antivirus. So the other thing that people may believe is that there are no more vulnerabilities in antivirus. Do we believe that? No? Sweet. Well, if you did, I'm going to try to change your mind. Here we have a little snippet. Who here uses Trend Micro? We have a few users. Oh, sorry, I messed that all up. So there was this vulnerability here. It was discovered by Alex Wheeler, and the vulnerability is inside the kernel driver. It's difficult to exploit, but the reason I say there's a high reward is because this piece of code is also probably used on their endpoints, at all those different areas, their email gateways. So it's something that can get you into lots of good data. So here's the piece of code specifically. Does anybody see the issue with this one? No issues? What about if we do this? So that piece of code right there is basically saying we're going to add a length inside of the allocator to the size of a structure, which is rather large, and we're going to add 4 to the end of that. And the issue with this is there's an integer overflow. They don't check to make sure that when you add all these values together, that it's not larger than any of the smaller pieces inside of it. So what you can do with this is, inside the default allocator, which affects lots of different file formats, you can say, I want a huge length, and it's going to return a very small length, and we all know what happens when that occurs. Basically, it'll allow you, every computer that's running Trend Micro, it'll allow you to take it over, basically the same as browser exploits or Macromedia, Flash. They are doing a check right there, right? If length is greater than cache length or not global unknown VMM, but that's not set. So they do a check, which is actually kind of interesting. It's ironic that they do have a check, but that check is disabled. Oh, right. That's it. That's why this check is disabled. Only for large things. Thank you. So another example we have is Bitdefender. Does anybody use Bitdefender for anything? No. Good. You're all safe. What's up? Yeah, Bitdefender is actually OEM'd by a lot of IDSs. I don't know of any products off the top of my head, but I did have a very large laundry list, and I probably should have included it. Basically, if you're using something that OEMs an antivirus, Bitdefender could potentially be the antivirus that you do use. So this is something that was discovered by myself and Alex Wheeler. And who here has been affected or knows someone who's been affected or has heard of someone being affected by a PDF parsing issue? Yeah, there we go. There's lots of issues with parsing PDF. It's an awesome file format. So basically, there's this area of code right here where you can supply 2 different 4-byte values, and then it adds them together right there into ESI. And again, this is the same sort of thing. It's another integer overflow. If we have 2 large numbers that are near the boundary of how large an integer can actually be, when we add them together, it's going to turn into a very small number. So it takes that, and it takes the added value and compares it to see if there's enough data. And if there's not enough data, then it will jump over, if there's already enough data, it will jump over this allocator. If there's not enough data, then it'll call realloc. And potentially, if you have 2 of those larger integers, it's going to change the memory buffer to something smaller than it needs right here. And if you guys can see the comment, can you see everything well up there? Do you guys see the bling thing? That's the part we like. So this is sort of the last example I have. So with the other ones, I kind of showed you code and showed you the sort of vulnerabilities. With this one, I'm going to show you demos, but not talk much about the code that's actually vulnerable. Who here has heard of Trusteer? Trusteer Rapport? Some of you? A few of you? Okay. So it has proprietary browser lockdown magic. And it takes that proprietary browser lockdown magic and it can prevent malware from attacking and stealing credentials as it would traditionally do with that magic, whether or not it knows anything about the Trojan variants. So I came up with internet rule number 1. And internet rule number 1 is, if there's 2 programs on a system and both of them don't like each other, whichever one gets there first and has knowledge about disabling the other is going to always win. Which is interesting because inside their white paper, they say that these are sort of the steps they did. And what they did was they infected a system first and then installed their program and then showed that, in fact, the malware wasn't able to take any data off of the system after the program was installed. And when I read white papers like this, I think that's kind of what they mean end users should be doing. Why scan your system first? Just install this product. So I think what happened was some sales guys invented this magic, because if you look inside of the data sheet, they also say that it comes with a rapid update mechanism. And if it doesn't matter whether or not the Trojan is known or unknown, why would you need a rapid update mechanism? So I think the engineers were able to save themselves a bit. And now we'll do some demos if I can get this to work. Here we go. So basically, Trusteer is this thing that runs on your system, and it protects certain websites. Basically, certain websites, when you're visiting them, it puts your machine into this more secure state. And one of the things it doesn't allow is things like screenshots and keylogging. Do you guys see the funny green arrow in the address bar? The funny green arrow shows you that Trusteer is indeed working and definitely protecting you from all of the internet badness. So basically, I wrote this program, super simple, just takes a screenshot, nothing funny about how it does it. So when we take a screenshot normally, this is what comes up, a big black screen. So basically, this is how Trusteer protects you. It sees you're taking a screenshot, and it replaces the normal screenshot data with basically nothing that would be valuable to an attacker. But if we run my program, basically it detects that Trusteer is on the system. Trusteer is completely running right now. You guys saw that black screen. And now, hopefully, if I don't have any more bad luck today, this worked. As you guys can see, Trusteer was completely disabled. In this screenshot, you can see my entire desktop, including the browser. Yeah, basically, anybody who's writing malware would just need to include one function that I have written, and they would be able to completely bypass and disable Trusteer, smash all of their product claims, and turn something that, that people probably pay a lot of money for into something that's completely worthless. If anything, the interesting part is, not only is it completely worthless at this point, but also if people expect that they can do whatever they want and Trusteer will protect them, and in fact it doesn't, that can actually cause more problems. Excuse me? Can you speak up a bit? Oh no, so the nice thing that they did, because it actually, the functionality that I'm using to turn it off is actually part of the program itself. So the nice thing about that is it needs to be able to do that from Internet Explorer itself. So basically, if you take over Internet Explorer and you're executing in the same process context, you'll be able to completely turn off this software. The other neat thing, who here has developed kernel overflows before? Okay, so they're hard, and I wasn't able to get it to completely